Hey guys, how you doing? Here it is, your ye old Professor Avelito. Hey, just want to thank you once again for your patience, and I want to apologize to you for not being able to make it to class. I had an impromptu situation that popped up that I needed to handle, and thus I hope that you received the email with enough of a heads up to be able to manage your time, and hopefully no one showed up to class and found that locked door. So. Quick little note, little typo. Meant to say we canceled module 10, not module 9. Module 10 handled all of the different appliances to protect network threats, against network threats. And module 10 is all about cloud and virtualization security. So, all of that cloud infrastructure that we discussed, just how can we protect it? What does that cloud infrastructure entail? What are the different components, the different agreements between the service provider and the organization. So that's kind of what we're going to be covering today in Module 10. Okay, our module objectives is to define what cloud is. Like cloud is a term that's getting tossed around quite a bit. Most people think it's ephemeral hardware sitting somewhere in the sky, but we're going to talk about what it actually is, what are the main components, how it's used, how it's managed. Go into virtualization a bit because largely all of the infrastructure, all of these services that are used in the cloud are virtualized or go through some kind of hypervisor. We're going to describe the security controls. So now that we know what a cloud is, how can we secure a digital cloud? And then listing all of the different protocols that we can use to protect the traffic in transit as it's flowing across different cloud services and different cloud components. Okay. All right. So let's have a talk about what cloud security is. I had a quick little video here to show you what is cloud computing as it relates to Amazon services, web services, AWS, which is used for everything. And if you experience some kind of issue with your cloud or any services, any streaming services in the last couple of weeks, you'll see just how embedded AWS technology is. So I'm going to let you watch this quick video so that you can see for yourself how Amazon, one of the largest, if not the largest, cloud service providers outside of maybe Microsoft's Azure, describes what is cloud computing to them. All right. I hope you enjoyed that video. Let me know if you're having any issues with it, but I can send you the link to watch it. It is an outstanding video. And as you can tell, cloud technology is ubiquitous. It means it's everywhere. I mean, from regular services, regular cloud services for domain directories or Active Directory to IoT devices to machine learning. I mean, cloud technology is used everywhere. And that presents a problem from a security standpoint because if it's everywhere, it also means that it needs to be secured. It means that it is a vector of attack for advanced persistent threats or even script kiddies to target, right? Because the cloud is the technology is sitting in a place that is somewhat accessible. So accessible to everyone also means that it is prone to security breaches, right? So that's kind of what we're going to be discussing today. Just a little go further into the cloud computing aspects of the cloud computing components themselves, and then the technology that's out there so that we can secure it. Oh, there you go. Okay, so what is cloud computing? It is essentially hosting all of these services, which could be in servers, it could be in a central storage, and also all of the networking components around it just to support whatever enterprise's goals are. They can be managed from a remote network connection. So somebody from a physical laptop like the one that I'm using now can remote into those services and still be able to manage it from anywhere in the world. So it doesn't take a lot of mental gymnastics to really understand like why cloud computing has become so popular in the past decade or so, just because it enables that convenient and on-demand network access with a variety of configurations for different computing sources, just across all different types of hardware capacities. So if right now I just needed a little tiny PC with just a couple of CPUs and a little bit of RAM, to now I need a full-blown supercomputer to be able to run machine learning and then having that scale on demand. I mean, that's really why these cloud service providers nowadays, are as huge as they are and why cloud computing is being implemented into everything. Something that's close to you guys is probably like gaming. You wouldn't think of cloud computing when you think of gaming, but think of all the services that are out there now, xCloud, Luna, I mean, GeForce Now. These are all running with virtualized or hardware components that are sitting in a data center somewhere. So again, just going back to that, if it's available, if it's ubiquitous, then it also must be secured. Many of the savings that organizations get due to from the cloud come from elasticity and scalability. Like I mentioned earlier, you can have right now have a need for a little tiny device or a tiny virtualized device or an operating system, or later on you can have a bunch of devices and they can scale literally with the touch of a button. If you run a script, you can spin up a bunch of machines. Another savings come from pay per use, which means you're only paying for the power or the storage that you need at that particular time. So that can create cost savings. We'll also discuss how those savings come with even the initial infrastructure build. So if I don't need a bunch of like my own data center or my own place to host all of these devices, then I can just hire Amazon or hire Google Cloud or somebody who already has the infrastructure in place and I can use their facilities, right? It's also on demand. It's there when you need it. You don't necessarily have to just have it on the side, almost like a hot, warm site. It's there only when you need it. And it's also has the capability to provide resiliency. I say has the capability because these devices are very easy to spin up. So if you want, you can create redundant devices, i.e., I only have one domain controller or one web server. Well, guess what? I'll just have another one on the backup and I can spin that up really quickly. So that's really where all the savings comes from when we talk about elasticity, scalability, pay-per-use, on-demand, or resiliency. Okay. Cloud architecture is made up of a couple of components. The first one is a thin client, something like this little black box right over here. A thin client is a device that has some hardware capabilities, but it is mostly used to connect to the cloud infrastructure and be able to access all of the services, the operating system, everything that's running on it. It doesn't necessarily have much in it outside of that connection. There's nothing really running on the device except whatever protocols allows it to access your virtual desktop infrastructure in the cloud. Okay. Then we have something called the Transit Gateway, and that is what allows all of the organizations to connect to all of the private organizations. Think of like a transit gateway as a highway. So all of the thin clients are the little cars, and they are traversing through the transit gateway to be able to get to the services provided by the cloud infrastructure. A serverless infrastructure is one where basically all of the servers, just like you saw on the third floor of our building, are invisible to the user because everything is in the cloud. So if you ever walk into a building and they have like a ton of different computers, but you don't see any data centers anywhere, it probably means that they're using a serverless infrastructure, which means that all of these servers, every web browser, domain controllers, file servers, everything is running in the cloud, and they're basically just using thin clients to be able to access those resources in the cloud. Okay, so that is the difference. Thin client, little tiny machine, all it does is connect to the cloud. Transit gateway is the tech and the protocols that allows a computer to basically access all of the services in that cloud infrastructure. And a serverless infrastructure is what we refer to as an organization that has basically gone 100%, one hundo into servers, into cloud infrastructure, and was nothing to do with physical infrastructure in their place. Okay, they just want to hire Amazon or hire Google Cloud or hire Microsoft Azure and a couple of other ones just to use their stuff. They don't want to have their own stuff. Okay. All right, so there are four service models that you need to be aware of. Really three, but the fourth one it's kind of like gaining popularity. Okay, the first one is software as a service, and that is where the vendor gives you access to certain software applications. Microsoft is really doing like going full throttle with that with Microsoft Office 365. I don't download Microsoft Word anymore. I go to the cloud, I go into a browser, and I go look up Microsoft.cloud, and I use their cloud Word application in the cloud. Google Drive and then Google Docs also does the same thing. You're accessing the application that's sitting in the cloud. It's not sitting on your computer. All of the scripts are technically running in your browser, just like kind of we described, but really all of the applications are sitting in the cloud infrastructure, and you access it to a browser. The second one is platform as a service, PaaS. And that means that you have the backbone and you have the ability, you yourself or your organization, to install specialized applications and run those applications on the cloud computing network. So if I made an app and I needed somewhere to run it, well, I would spin up a virtual machine, a virtual computer, and that, will have all of the resources in it to be able to run my app, and that connect to that infrastructure can access my app. That is the platform. So they provide the platform, the ability for you to run your app. Whereas software as a service, you're accessing their software in the cloud. Okay. And then we have infrastructure as a service, and infrastructure, think of it as like a physical components. You can access all of the physical components that they have in their data center. So if they have a server blade with, I don't know, 50 CPU cores and 500 gigs of RAM, then you can access all of that and basically do what you want. That includes installing your own APIs, your application programming interfaces, so that you can have your own operating system, so that you can have your own software. I mean, think of it as more like a ground up approach to cloud service infrastructure. So if we just going from like low to high, infrastructure is like all of the capacities and devices and computing resources. Then you have platform is the ability for you to install your own APIs, your own like background code. And then software as a service is when you can access like specialized software applications that they have available for you. Now, there's a term, though, there's a fourth service model that has just gained popularity, and it's called XaaS, and that is anything as a service. So that is a very broad category of subscription services that are now available to you. I mean, it's just a ton. It can include all of these three things, all of these three service models, software, platform, and infrastructure. But anything as a service also includes the networking endpoints. So routers, switches, IoT devices, anything that can be computed can be virtualized, and that is technically now falls into the anything as a service model. So basically, all of the miscellaneous, all of the routers, components, gateways, whatever you want that connects all of these devices as part of anything as a service. IoT devices as anything as a service. Okay. All right. So the whole point when we say we're managing the infrastructure, we're saying that we can access it ourselves and be able to go up there and manage it. You can hire personnel within your own organization to do that, or you can hire a third party, somebody to manage it for you. That's what we mean. The whole goal is to conduct integration of all of the different services. So if I have an organization and it has a financing department and it has a I don't know, HR department, or they have a security department, then all of their services will be hosted on the cloud and they're still gonna be unified. Meaning I'm not going to have some components in like the ground sitting in my own building. All of the components are going to be sitting in the cloud and they're all going to be talking to each other. Okay. The HR people will be aware of who the financing people are if they need to. And the security personnel will be able to have oversight. So that's what we mean by having services integration. Every enterprise still, just like on a regular on-premise solution, should have resource policies. All right, they should know who is going to gain access to what, for how long, in what hours, depending on what role. In cloud computing and all of the cloud computing applications allow you to do that, allow you to have your own domain controller in the cloud and to be able to have that level of management. That's what we mean by resource policies. You can hire what's called a managed service provider, and that is a third party company that would basically manage the entire infrastructure for you. Okay, they charge quite a bit of money, but they assume the role of what a traditional on-premise IT organization would do. So instead of having a one or two people on your on-prem just taking care of the entire IT and making sure that all of the IT components are talking to each other and they're being ran and they're being secure, a managed service provider will do that for you. Okay, there are many of them out there, but they provide maintenance for the servers. They make sure that you have a data backup, disaster recovery plan, making sure that authentication is strong as it needs to be. They monitor the network with a SIEM and IPS, make sure that all that's running right. And also manage the infrastructure, because believe it or not, even though the infrastructure is in the cloud, you are responsible for making sure that it is updated, that it is running the latest security configurations. Also making sure that the cloud storage, it's, you only have what you need, that you're only accessing the data that you need, so you don't run or experience exorbitant charges for having data on your side that you really do not need to have. Okay. There are many security issues, just like on an on-premise, the infrastructure that you need to be aware of, and that is unauthorized access to data. So you still got to be concerned of you making sure that you're giving the proper personnel the right amount of roles, and that no one from the outside can have access to the inside of your infrastructure if you don't need it. You still have to have the perimeter defense. You still need to have your DMZ, because it could result in the data getting exfilled out of your organization or resources being accessed. That's still a concern in the cloud infrastructure. Visibility, since you don't have access to the hardware yourself, you may think that, oh, visibility is not really my concern anymore, and that's not true. You still need to make sure that you have security mechanisms, logging, alerts set up, and that you have some kind of dashboard set up so that you can maintain situational awareness of everything that's running in that cloud. You also, especially when it comes to infrastructure as a service, need to be aware of that you are in charge and responsible for managing all of your application programming interfaces, your APIs. Because if you don't and they're unsecure, or you have some kind of faulty code somewhere, then users can exploit that. Attackers can exploit that to access resources and access information that they typically wouldn't have access to. You're also in charge of making sure that you're in compliance. So there are many regulations that are out there that manage organizations based on the amount of data that they hold, or the type of data that they hold. For example, if my organization was handling medical data, then that medical data, so even if it's sitting in the cloud, I still need to make sure that it is properly encrypted across all of its stages. During storage, during transit, needs to be secured with the right protocol. So you still have to make sure that your MSP or your own internal manager has the right security controls and the right access and the right audit logs to make sure that that data is being secured properly. And then because it is software running in the cloud, you still is responsible for securing the systems that data is running on, or those or that software is running on. So system vulnerabilities still need to be mitigated by making sure that everything you have is being patched correctly, and making sure that you have a routine checks, alerts set up in case one of those vulnerabilities could be exploited or is exploited. Right. And on top of all that, okay, or to categorize all of those security controls, we discussed conducting audits on on-premise devices. You typically want to conduct audits of every single security control to make sure that one, they are actually meeting the goals that you want for your security. Meaning, if I encrypt, I don't know, if I encrypt my data with 256-bit whatever, right, some kind of encryption, that the actual application of those controls are being applied across the entire organization or where appropriate, right? That's how you go back and check to make sure that your controls are actually meeting the end state that you want it to meet. Using regions and zones, it's also important, akin to subnetting, making sure that you have all of your devices, all of your important sections segmented, provides layered type of a layered approach to security, and introducing redundancies so that you have the highest availability across all of those zones as possible. So like on the DMZ, you may want to have two web servers or one on backup. You may want to have two DCs and so forth and so forth, double wall firewalls, things like that. Secrets management refers to, hey, let me make sure that I have the strongest encryption possible while balancing availability and balancing security, right? Just making sure that all of those keys are being stored in a virtualized HSM or somewhere where all those secrets are being kept. It's going to be extremely important, okay? While still keeping in mind that you need to remain flexible and scalable, right? And then finally, enforcing the functional area mitigation. Okay, guys. So now let's quickly go over a couple of specific technologies that you can use in order to secure your cloud infrastructure. Right at the top, starting with a CASB, also called a cloud access infrastructure, and that's like a suite of technologies and tools that you can use to secure your network. This includes, so it almost acts like an automatic IPS, IDS, and firewall all in one. It is a software that typically resides on on-premise infrastructure, but in this case, we're applying it to a cloud infrastructure. I mean, it does the very same thing. It is one device or one particular set of tools that allows us to secure just an entire suite. Think of like Microsoft Office as a suite. A CASB provides a whole suite. So that includes securing infrastructure across all of its cloud service provider models. So infrastructure as a service, software as a service, just everything, platform as a service. That means it takes a look at softwares that are running at the layer 7. It takes a look at all of the infrastructure in between it to include the API, to include a network flow, to include host logs. It examines it and makes sure that there's nothing there that's being ran maliciously or installed maliciously or transmitted maliciously. It can send up alerts. It can quarantine things. Just think of a CASB as almost like a robotic automatic IDS, IPS, and firewall all in once that can conduct deep impact and inspections, and it can detect if something malicious is running on your infrastructure. Like it says, it acts as a gatekeeper to also make sure that all of your policies are in place, and then also lets you know or informs you of any recommendations that can you use to further secure your infrastructure. The next thing, if you guys have ever heard of a next generation firewall, well, this is kind of the equivalent of that. It's just like a really, really smart firewall that does deep impact inspections like we discussed last week. But in this case, it's called the next generation secure web gateway. Whenever you see SWG, just think next generation secure web gateway, and it can inspect all of the traffic coming in and out. And it can monitor the applications. Some SWGs can also do heuristics, and like we discussed in heuristics, it could observe traffic that it's never seen before, and based on the pattern of the traffic, it can tell you. There might be some command and control or some beaconing happening, or maybe some really, really smart data exfil, and it can alert you of that. And then a cloud firewall acts just like a regular firewall, which just looks at traffic coming in and out, and it looks at its list and says, hey, yeah, this traffic is allowed into the network and not. It's really very simple, but it's just a virtualized instance. Last week, we discussed OpenSense, and OpenSense is a software solution that can also be virtualized in the cloud. So very, very, very similar. The difference is that it's being virtualized. Okay. Okay, so what we must understand when it comes to cloud is that there isn't like a super defined conceptual model thus yet, like kind of how we have the OSI model or the TCP/IP model for on-press. I'm sure you guys all know the 7 layers of the OSI model. We're not going to go into that. But there is no such thing for cloud because the infrastructure can be so flat, right? And almost everything is virtualized. There is no typically virtual physical devices if you want it in like the traditional sense, right? That layer one in a fully cloud infrastructure doesn't really mean what you think it means because a lot of those components, a lot of those links are logical. They can be logical. They do exist. There are physical links, but a lot of the ones that you make up on in the cloud, when you access those services, they're actually logical. So I'm connecting a virtual switch to a virtual router. There is no virtual, there's like virtual cable, right? They're just communicating with each other. That's why these models, the way we know them, don't really apply. There is one that it's kind of gaining traction. It's the one that I'm showing you here. And it has 5 layers. Physical infrastructure, which is provided by the cloud computing provider. The same thing, the hypervisor is the virtualizing software that will be a layer 2. So whatever hypervisor is that they're using. Then the third is software defined data center. Those are available in the software as a service and platform as a service, infrastructure as a service. Service models, if you're using a software as a service model, typically the cloud service provider provides you with all of the infrastructure that you need to create that software defined data center. But if you are using the platform as a service and the infrastructure as a service models, then the customer will be responsible for really defining basically all of the software and all of the APIs that are running on top of that software. Then the fourth is the native service. So that's what the user sees. Think of it as the front end. So almost like the application layer in a way. But it's more like in the back end, it's like pseudo application layer. And that's where if I click a button to make an order on my application, then that's what gets ran in the background to search for that order and process that order. And the responsible person is the customer being the person who is accessing the resources or who is buying the resources from AWS or Amazon. And then the application experience, that's also partly the person responsible will be the customer. By customer, I mean the person who is buying access to the cloud infrastructure through AWS or Microsoft or whatever. And they're the ones that are in charge of making sure that the interface, the actual buttons that you click are actually working. So once again, the differences between 5 and 4 is application experience is like me touching the actual application. Native experience is everything that's happening when I'm touching the buttons on the application. The customer is the person in charge of making sure that those components are secure and making sure that those components are working as they should. And this is probably the closest model that can describe the entire infrastructure in a cloud service provider or using it through cloud computing. We all know more or less what virtualization is. We're taking a physical computer and we're breaking down that computer or separating those components so that we can create other tiny little computers inside of it. That's in a nutshell what virtual machines are. They're like little baby computers, right? They're virtualized. They're not sitting physically on anything. They're just running as a virtual instance of themselves, right? And these little tiny baby computers need to be secured just as well. And that is could not be even more true than when you're talking about cloud computing, because largely I would say 70 to 80% of everything that's running in the cloud or running in a data center is being virtualized. And that includes all of the networking components that are, the routers and the switches that are connecting all of these things, all of these virtual machines. So the same security principles need to apply. Okay, so when we're talking about virtualization, there are a couple of concepts that you need to be aware of. The first is, what is host virtualization? When you say I'm virtualizing a host, what is it that I'm talking about? It means that I'm going beyond the operating system. I am virtualizing the entire PC. So I am virtualizing a PC that the operating system is actually sitting on. That's what I mean by the entire operating system environment. I am virtualizing all of the network interface cards. I am virtualizing the amount of RAM it has. I am virtualizing the amount of storage that it has, all of the CPU power, everything around it. And then when we say a virtual machine is now a machine that has an operating system on top of that virtualized hardware. So host virtualization, I am legit virtualizing the entire machine. And I know it can be kind of confusing, but the virtual machine includes the operating system and all of the software that's running on that operating system. The way that virtualization typically works, if you have a host system, which can be virtualized or it can be physical, and that's where all of the operating systems and all of the softwares are running on it. And you can use virtualization for basically anything that you want, like multiple physical servers. It can run on a single physical machine. Typically we think of servers being ran on like a large blade, which is called a server blade, right? It's just super powerful, but you can technically run any computer. You can virtualize any servers on just any physical machine as long as it can handle it and it has the right amount of resources. Like the picture depicts. The host system hosts the virtualization software. We also call that a hypervisor, and then the hypervisor is actually what's enabling the virtualization of the virtual machine. Virtual machine being a host machine with software and operating system sitting on top of it. Okay. There are two types of hypervisors that you need to be aware of, and that is type 1 and type 2 hypervisors. Type 1 hypervisors are running directly on the hardware, right? The hypervisor is not being virtualized. It's running directly on the hardware. Okay. And that's where you can install all the operating systems that you want right on top of it, and it's just the closest to the hardware. Whereas the Type 2, it's running on the host operating system. So let's say that we have a piece of hardware, and we install Windows 10. If I were to download Microsoft, I don't know, I'm sorry, VirtualBox, or I would enroll VMware and then install it on Windows 10, then that would be a Type 2 hypervisor. You typically see Type 1 hypervisors when you have server blade. Okay, so if you buy a VMware or a Cisco server blade, they will have their own hypervisor sitting on top of it. Okay, a Type 1 hypervisor, which is like the proprietary ones, and it's sitting right on it. There's no operating system running on top of it. It's just that hypervisor, and its sole purpose for that blade is to create another virtual machine. Whereas a Type 2, it would have like Windows or Linux running on it, and then you're downloading VMware, or if you have a Mac, you're running Parallels or UTM or whatever, and then you're installing or virtualizing through that hypervisor. Then we have specified, like these specified virtual operating systems, okay, that run containers. A container has just the services, just the amount of RAM and physical capabilities to run a single application. Just a single thing can be running. So if I wanted to run, I don't know, Spotify on just a little tiny piece, and all I need is like 50 megs of RAM, then that container will have just enough to run a single application. So when you see containers, think all I need to virtualize is a single application, and I don't need an entire host system. I don't need an entire host OS and a hypervisor to the all of that. I'm just going to put it on a container, and that container has everything it needs just to run that single application. It has all the binaries, it has all the libraries, and then on top of it, it has the application itself. Instead of it running on a hypervisor, it's running on what's called a container engine. There are many, many of them out there. I'm sure if you Google one, you can download it yourself and try to run whatever application that you want. But it's instead of me chopping up some resources to run an entire operating system, to run a whole software suite on top of it. No, you use a container if you're running and just a single application, just like one application or whatever, just a single tiny. So you're even splitting up your resources even lower, okay, which can lead to quite better management of resources because now I'm like really grabbing just what I need to get the job done to containerization. Okay. Now, what are the advantages of virtualization? I think some of them are pretty obvious, right? It can reduce costs because I no longer need to buy three server blades or three desktop machines to run three servers. I can technically just make one really beefy one and then create a bunch of different servers and virtualize a bunch of servers on top of that. It also allows for what's called the uninterrupted server access to users. So in case I need to move one machine from one device to another, I no longer need to build another machine and then transport it somewhere. I can legit take an image of that virtualized instance, copy it, put it on a USB drive, whatever you need, and just transfer it someplace else. It's called live migration. I can do that without having any impact as to anyone else. And one that is not really here, it's that there's it really easily replicated, right? So I can create just a copy of it, keep the original one running, and that's what we mean by availability. Keep that one running while I install the other one and then bring it online. So many benefits to virtualization, just the management of those physical resources. It's great. Okay, so what do we call a software-defined network? Well, a regular network runs on-premise network runs physically, right? We have all of the physical components. We actually have like real switches and real routers connected by real cables. In a software-defined, we have all of the same components, but they're all logical, right? We have a virtualized router, a virtualized switch, and then there's logical connections between those two, and then connections to all of the workstations, all of the servers. This is done by separating something called the what we call the control plane from the data plane. The control plane being the where I get to decide what protocols are being used. So think of it as like layer two or physical, or even layer three of the OSI model. I get to decide what protocols are being used to enable those connections, and then the data plane is where those connections are, where that data is actually running through. So I am controlling the flow, I am controlling the way that they're communicating, and then the data plane is actually where the data is flowing through. If traffic needs to flow to a network first, it gets the go ahead or the permission from what's called the software defined controller, which through the network policy, it decides, hey, these two endpoints are communicating through the agreed upon protocols with the agreed upon packet frames, and then data can start flowing through the network. Okay, but first is that approval by the SDN controller that sits on the controller plane. Hey, are these two endpoints supposed to communicate? If so, what protocol are they going to use to communicate? Software-defined visibility is the framework that allows the users to create programs where like critical functions can be automated, and it allows network administrators to automate many different functions, which include just evaluating all of that traffic and making sure that that traffic is valid for the type of traffic it is, and it can be flagged as malicious if it's outside of the boundaries of what's normal. Going back to these devices being able to use heuristics, behavior-based signatures to determine if this traffic is abnormal and whether it should be flagged or even stopped and blocked. They enable the adjustments to all of the different traffic mode configurations for any inline security tools. And when we think inline, that means that the device it's sitting inside of the logical link, so it can see traffic unfiltered flowing back and forth in order to make those determinations. And software-defined visibility allows for additional IT management operations, and that includes the analysis, that includes the enabling of the logging, that includes being able to analyze those logs and create dashboards to create baselines to determine what's normal inside a network and what should be flagged. There are some security related advantages to virtualization. When you virtualize something, you're able to create a snapshot of that machine, which can help with digital forensics. So if I have a machine that's running weird, I can use I can just grab a snapshot of it, go and virtualize it someplace else and see what's running on it that maybe should not be running and is causing issues, which allows for the facilitation of testing of a specific configuration before it goes into production or before it goes out. We're all aware what sandboxing is, and sandboxing, once again, is when I am creating an environment that's very similar to where the machine should be running, and that allows me to test the virtual machine for any malicious components or any vulnerabilities that may be existing within it. And this is something that can be done very, very easily through a virtual machine before I can, instead of a physical machine where I'm going to have to go through a lot more hoops in order to catch that image and then being able to make that image run on a very similar environment. Sandboxing is super easy when we're talking about virtual machines. Okay. But there are many security concerns. For example, not many when we're talking about virtualizing, there are many components that need to be secured. We're talking not about the whole system itself, but also the the operating system sitting on top of it, and then the hypervisor sitting on top of that. And typically, the security controls that we have were really designed for a single physical server. Now we're talking about 3 or 4 layers of virtualized components that are all talking to each other. So that can be a bit more difficult to secure. Now you have to make sure that there are 3 different components that are constantly updated and that need to have secure baselines. There's also the issue where virtual machines can escape. You can lose track of your virtual machines if you start creating too many of them and you don't have some kind of inventory mechanism. That's called virtual machine sprawl, where you just start spanning virtual machines that may not be secure, that may not be necessarily secure. You forget about them, and you no longer keep track of them, and somebody can access those virtual machines that are still connected to your network and be able to laterally move throughout your network. You also have to make sure that your virtual machines that are talking to each other have the appropriate controls in place so that they're not like jumping from one enclave to another or jumping from one VLAN to another. So the more virtual machines you have, the more important it becomes that you start keeping track of them and also keep track of all of the access controls that you have applied to them. I'm sure you guys have heard of SolarWinds. If you haven't, SolarWinds is a software that large enterprises use back in it, still use today to keep track of all of the virtual machines and their statuses in the organization. It can create an inventory, like over here we have virtualization assets. It can give you a summary of their statuses. It can give you a summary of what kind of resources they're currently using or not using, and also give you a map that tells you how they're all logically connected. So extremely useful for large enterprises if you're just going to keep using virtual machines and in cloud computing. You want to see how those virtual machines are logically linked. Okay. There are a couple of security protocols that you need to be aware of. SNMP is one that you use in an on-premise, and that's when we are managing devices over a network, and you want to do it remotely. DNS still applies because these virtual machines are going to reach out to try to get a reference for a IP to a domain name, so that's still happening. File transfer protocol still applies. All of these secure email protocols that we described in class still apply. LDAP is when you're using any type of Active Directory control. You have a domain controller, that protocol is still there. And it's not only IPv4, we also have IPv6 that are still applied to a cloud environment. We discussed Simple Network Management Protocol before. But SNMP is used once again to manage the devices in a network from a remote location. Instead of me going to each one of the devices independently, I am now going to those devices through a single laptop, and I am going to go in there and monitor, manage, and configure all those network devices to make sure that they are configured in the most secure way possible. There is something you need to be aware of called a community string. And a community string is a password that enables the agent that's sitting on that physical machine that's being inspected, that's being monitored, to communicate out to the administrator. Okay. If you guys go to this link inside, let's say that you are using SNMP in your network, and you go into this registry key that I put on the board right here, HKLM system. If you just go down that path and you see valid communities, you'll be able to see all of your different community strings. And once again, that's what enables the communication between the agent that's sitting on the machine, that's being monitored, that's monitoring the PC, with the actual client, the server or the remote machine that the admin is using to access that machine and be able to configure it. Security vulnerabilities were present in versions 1 and 2 of SNMP, so make sure that your organization is only using version 3, which alongside usernames and passwords, it's also using TLS and SSL to be able to secure those connections. Okay. We all know by now that DNS is kind of like the Rolodex that allows you to communicate with the big old Rolodex in the sky and match IP addresses to domain names. So that way you don't have to type in 76.143. Whatever to go to Google, right? So DNSSEC, that's just a series of security extensions that allow you to protect your network against DNS poison and DNS hijacking. And that's additional resource records and message header information we can use to verify that the data as it's being transmitted has not been altered in any way and it's not being spied on. It uses asymmetric protocols, which asymmetric we know is composed of a private and a public key, and also hashes to verify that the data was not modified in transit. Okay. FTP, we know that it's used to transfer files from one machine to the other. Typically, you have a client, and from a command prompt, you sign in, and then you'll be able to gain access to all of the files and copy the files over. But it is vulnerable because FTP does not use any type of encryption. So if I'm using solely FTP, every single file that's flowing across the network, then an attacker can conduct a man-in-the-middle attack, and it can basically eavesdrop on whatever and maybe copy whatever is flowing through that network. That is why you want to use one of the secure versions of FTP, either FTP Secure or Secure FTP. As secure, the big differences with these two is that one uses SSL, which is FTP Secure, and TLS to encrypt commands. It can also use digital signatures. Remember, the digital signatures are formatted in this X509 format for digital certificates. And then Secure FTP is using not only username and password, but also SSH, which technically SSH also uses SSL or TLS in order to do that. Another one of the big differences is that FTP typically has two control channels. It has a control plane and it has a data plane. So I control the flow of data with one. I make sure that I have a good handshake before I send data over. Whereas SFTP uses two, just because it's encrypting everything over the same, and it's also monitoring the connection to make sure that it is staying remaining secure. Okay, that's one of the big advantages of using one of these secure methods. Is now there is a single plane that is being secured constantly as the files are being transmitted across the network. When we're talking about accessing emails, we know that we send a packet out to a server, and that server sends us a copy of the email, and that's what we view on our email clients. Okay. There are two secure protocols that you should be aware of, and that is Simple Mail Transfer Protocol and Post Office Protocol. Those are the protocols that we typically use to interact with web servers. But those are kind of old now. You can use them internally, but when we're reaching out to the internet, we want to use something like IMAP, which tends to monitor all of the content that's being downloaded into your web server, and that's why now we have junk folders, because it can flag down potentially malicious links, potentially malicious files, scripts, and also can encrypt outbound email messages just to make sure that they're not being eavesdropped on. Lightweight directory access protocol is used to access databases, is used to access domain controllers and all of the data that's sitting in these domain controllers. Sorry that my big old circle and face is sitting on the domain controller picture. But yeah, it's what we use to be able to securely access all of the records of every single user, all of the records of every single object that's sitting and is being managed by the domain controllers in your organization, and it can make it possible for almost any application that's running to obtain that directory data. So LDAP is probably the best defense that you got against an LDAP injection attack, but primarily because it examines every single thing that's being inputted to make sure that the right input validation controls were implemented, and it can flag down anyone trying to insert SQL commands to try to dump tables and gain access to information that they typically should not have access to. Okay. As we all know, IPv4, IPv6, IPv4 was the first or second version, believe it or not, of in the Internet Protocol. IPv4 was probably the best version at its time because there weren't that many machines. And then eventually they figured out, hey, we're eventually going to run out of IPs. So IPv6 was invented so that it can add end-to-end encryption. It makes this much more, it gives us a much broader IP space. And that end-to-end encryption also makes it harder for people to conduct man-in-the-middle attacks. It also supports what's called the Secure Neighbor Discovery Protocol, which can send cryptographic information just to verify that the endpoint that's trying to communicate is who they claim to be before that data can be sent. This means that if I am trying to conduct an ARP poisoning attack, it's not going to work because it's going to match who the person that I should be communicating is against its own records, right? So if somebody's trying to communicate with me that it should not be, it's going to let me know. It's going to be able to flag that down. If somebody's trying to pretend to be a MAC address that they are not, it's going to let me know. And it's going to stop the communication before it happens. So that's an enhanced security feature that IPv6 has that IPv4 does not. That's why IPv6 is kind of critical when you're talking about cloud infrastructure, because you are leaving the network. And the moment you leave your network to go to the cloud, there are way more attackers and more devices and people that are waiting to eavesdrop on your communications and try to spoof their Macs to make them communicate with you. With them so that they can take advantage and exfiltrate or copy or gain access to the data that they should not have. Okay, very good. So now let's go into our knowledge check activities. Which cloud security control provides reliability and resilience through the duplication of processes across geographical areas? Is it conducting audits? Is it implementing secrets management? Is it using regions and zones? Is it enforcing functional area mitigations? Which cloud security control provides reliability and resilience? Think of those two terms through the duplication of processes. If you said using regions and zones, then you're absolutely correct. When we have different zones, we can achieve that reliability and that resistance because we're able to duplicate the processes, even duplicate devices like the domain controllers or the web servers across all of these areas, which brings a lot more resilience and it makes sure that your customers can have a reliable environment that they'll always be able to access their services through. Okay. Second question is, what virtualization technology separates the control plane from the data plane on networking devices such as switches or routers? Is it SDV, which is software-defined visibility? Is it a hypervisors? Is it a container? Is it a software-defined network? Which one is it? If you said software-defined network, then you're absolutely correct. A software-defined network virtualizes all of the physical parts of the network between the control plane and the data plane. It's what enables those digital links, those logical links between networking devices and also networking infrastructure. And it's what pretty much enables all of those connections in a secure manner by having the control plane and the data plane. And the final question is, what type of networking service is potentially susceptible to LDAP projection attacks, lightweight directory access protocol? Is it directory services? Is it domain name service? Is it web service, or is it a mail service? Which type of networking service is potentially susceptible to LDAP? If you said directory service, well, that's in the name of the LDAP. Anytime that you keep connecting to an LDAP to a directory domain controller, you're using LDAP, which is the protocol for using and accessing access to all of the different users, all of the different objects inside of your network. All right, guys. Well, in summary, we went through quite a bit. Cloud computing is huge, but I hope that you understand what a cloud is, what the cloud offers, how it differs, what are the benefits when compared to an on-premise service. All of the service models, software as a service, platform as a service, infrastructure. Think of software, you're accessing a single application that's sitting in the cloud, platform accessing the resources that allow you to code your own application in the cloud. And then infrastructure, you're accessing like computing power, you're accessing storage, and that allows you to create your own platform, your own software right on top of it. And anything as a service is everything in between. Think of IoT, Internet of Things, containerization. All of these things fall under anything as a service. We discuss all of the potential security issues, right? Of you that you still need to be able to make sure that you have secure baselines for all of the configurations, all of the software. If you're doing platform, you got to be concerned about APIs being secure. If you're thinking about emulating a specific virtual machines, then you need to make sure that they have secure baselines, right? The operating system, the hypervisor that you're using. And then we talked about all the different protocols that are still present in the cloud, SNMP to remotely manage devices, DNSSEC to secure from DNS poisoning, all of the security that you need around DNS, FTPS and SFTP to make sure that you're sending files securely over the network. And then when protecting web servers, making sure that you're using IMAP instead of SMTP and POP3 to make sure that your communications across email are being secured. I hope you enjoyed this class. Once again, I wish I was there to interact with you. I apologize again for not being able to make it and canceling class for you. But if you have any questions, please reach out to me and I will gladly answer them for you. I hope you enjoy the rest of your weekend. I look forward to seeing you on Thursday. Make sure that you complete all of your assignments no later than Wednesday. Okay? Have a great one, guys. Take care.